Hey, year eights, we're trying something new for this lesson, so hopefully you'll enjoy the video. I'll take you through some of the guidance for this lesson, and obviously you can pause it as you go along if you're feeling it goes too quickly, or you can speed through if you finish the activities when you need them. Okay, so just a bit of lesson preparation. Make sure you get down the title. So the title is "What evidence is there that the crust on Earth moves, or just the crust moves?" You'll need your exercise book and the resources in front of you. I'm going to start off the lesson with 2 recap questions from previous learning. Okay, so I'll put the answers on the next slide so that you guys can check your work and make sure you've got the answers. But the first one is name the 4 layers of Earth's structure. So we did that last lesson. You should be fairly confident with that one. And then the second question is choose the 3 correct statements. So the Earth's crust is the thinnest layer of Earth, made up of solid broken up slabs of giant rock called tectonic plates, the hottest layer of Earth, and where human lives. So 3 of those are correct, 1 is incorrect. Obviously write those down in your books. Pause the video now so that you can have time to answer those questions. Okay, so answers are, so obviously your structure of the Earth, question 1, starting from the deepest, go inner core, outer core, mantle and crust, and then your statements are 1, 2 and 4 are correct. Okay, so just going back to that, we've got 1, it is the thinnest layer of the Earth, 2 is made up of solid broken up slabs of giant rock called tectonic plates, and 4, it is where we live, human beings. So correct any of your work, make sure you're happy with that, add any detail if you've got them wrong in green pen, and then we'll get on with the lesson. So just to start things off, I want to go through some key words for tectonics. So we looked at this a little bit last lesson, but as you can see from this map, the crust of the Earth is broken into huge slabs of rock, and those are called tectonic plates. So some examples include the African plate, Eurasian plate, North American, South American. Those are some of the biggest ones. There are obviously much more smaller ones as well. Okay, but where they meet, that's the really interesting part of things. That's where we get all excited about earthquakes and volcanoes. But those are called plate boundaries. You might want to jot those definitions down after the next slide. Okay, so quick check on your understanding before we do that. So what happens at plate boundaries? This is a map that shows volcanic activity. Okay, so I'll switch between it and I want you to have a think about what's actually going on. So I'm going to show you a map that shows volcanic activity. What pattern do we notice? So if I go back to our tectonic plate boundaries, those black lines, what do we notice about where volcanic activity is? Is there a pattern? Have a think. Okay, now moving on, think about what else is happening in these areas. We're also going to look at earthquakes. So if we map that on, map of our tectonic plates and a map of the earthquakes, what do we notice going on? Okay, so you should have noticed that along our plate boundaries we've got lots of volcanic activity and we've got earthquakes, and that's obviously what we're going to look at during this unit. Why are those happening? How do they affect people? Those sorts of things. Okay, so keywords for tectonics, quick mix and match activity. I want you to write down the keywords, so earthquakes, tectonic plates, volcano and plate boundary, and I want you to match them up with the keywords. So which one is an opening in the Earth's crust from which lava and ash can come out? Which one is where 2 tectonic plates meet? Giant slabs of giant rock which form the crust, and a sudden release of energy within the Earth structure. Okay, so pause your video and match up those keywords. Okay, so our question for today is thinking about how do we know that tectonic plates move. So there was a theorist called Alfred Wegener, and he had a number of different theories about what was happening with plate tectonics. He was the first person that suggested that tectonic plates move, and this was a fairly radical idea. We thought that our world was fairly static before this happened, and there was a number of pieces of evidence that he cited to support his arguments. The first one is the jigsaw fit. The next one is fossil evidence. And I want you to look at these maps and try and work out what he saw in these theories. Have a think about it for yourselves. Okay, so the jigsaw fit is quite simply the fact that our continents in certain areas seem to fit in really nicely with each other. Okay, if you look at South America and Africa, they kind of click together and they have a similar sort of shape. And he suggested that that's because once upon a time they were actually part of a continent, supercontinent called Pangaea. Our second one is fossil evidence. So again, if you look at South America and Africa, we found similar fossils of the same animals in different continents. So obviously we've got the Atlantic Ocean splitting up South America and Africa, and yet in these different areas the same fossils were appearing. Okay, so that was something that he felt was another piece of evidence to suggest that once upon a time these continents that we have today, they were part of one giant continent called Pangaea. The next one is geological evidence. So the rocks are a very similar age. So the rocks in South America and Africa have a very similar makeup. They're over 200 million years old, and so they have a similar formation. And so he combined all of these different ideas to suggest this idea about Pangaea, the supercontinent. The last piece of evidence came from a man called Harry Hammond Ness, and he looked at the age of rocks. So in this map we can see the age of different rocks. So our more recent rock is in red, and our oldest rock is in dark blue. So Harry Hammond Ness looked at this and he saw several things. So my arrows here point to these different pieces of rock are the same age, even though there's gaps between them. Okay, so he suggested that the sea floor was actually spreading away from itself. So when it came out, obviously it's the same age, and then as it moves apart, it all remains the same age. Okay, and this was exemplified also by the areas in blue. So those areas in blue, much older, and then they took their time, they've spread it away from each other, and finally we can see them as they are, thousands of miles apart from each other, but the same age. Okay, so these guys combined their ideas to suggest the idea of Pangaea, this giant continent. So what I'd like you guys to do as your main part of the class is to write down the subtitles: jigsaw fit, fossil evidence, geological fit, and seafloor spreading. And under each subtitle, I want you to write your own explanations of how we know that tectonic plates move. If you want to, you can pause the video and go back to my explanations, jot down your notes and add to them. Okay, so have a go at that. So I've written a model answer for you just so that you can check your answers, make sure you can make any improvements. So if we think about this question, one piece of evidence is geological evidence. So I've cited what the evidence is. This is where the rock types in east of South America and the west of Africa are the same. So I've explained what that piece of evidence actually is. And then I've said suggesting that they were once together. I've explained why that says that they are evidence of tectonic plate movement. Okay, so double check your answers. I want you to make sure that you've got several of these written down, so you might give 2 pieces of evidence in your question. Have a go at another one if that's the one you've done. Okay, so that's it, everyone. Hopefully you've got a good understanding of how we know that plate tectonics move, and we will see you here for the next lesson. Okay, send me an email if you think these are useful videos.